In this video, we're going to test our knowledge on the point of inflection. Now, do you remember that if I say the point of inflection, you need to think the second derivative. In other words, when the second derivative is going to be equal to 0. In order for me to find the second derivative, for this function, I need to find the first derivative first. So dy by dx is going to be 3x squared minus 12x and plus 5. Now from this, if I find the second derivative of the function, that's going to be the derivative of the derivative, which is 6x minus 12. If I make this second derivative equal to 0, then it stands to reason that 6x minus 12 is equal to 0. And if I solve for x, I find that x is going to be equal to 2. But they ask me to find the whole point of inflection. I so far found the x-coordinate for the point. So what I need to do next is find the y-coordinate. When I find the corresponding y-coordinate for when x is 2, I must take that x value and substitute it into my original equation. In other words, wherever I see an x, I put a 2. So I get 2 cubed minus 6 times by 2 squared plus 5 times by 2 and plus 9. When you work this out on your calculator, you find that the y is going to be equal to 3. In other words, the point that I'm looking at is the point of 2, 3. Now the next part of the question is this point actually a point of inflection? And we need to test this using our table. When I test a point to see that it is actually a point of inflection, I could use the first test, which was the gradient, and the gradient to the left or to the right of that x value had to be the same. Or I could test the concavity, and the concavity to the left and to the right of that point had to be the opposite. As testing the concavity seems easier to me because the equation is quite simple, I'm going to go with test 2. The way that we do this is we take the point that we had found, and the point had an x-coordinate of 2. Find an x value very close to 2. I'm going to choose 1,9 on the left and 2,1 on the right. Now substitute this value of 1,9 into your second derivative. In other words, work out the answer for 6 times by 1,9 or minus 12 and see what your answer will be. Then do the same for 2,1. Take your second derivative answer and substitute in 2,1 in the place of x, and also look for your answer. When you work these answers out, for the estimate on the left, you get minus 0,6. For the estimate on the right, you get 0,6. Now don't even bother to look at the numbers. The important part is the sign. If I have a negative for my second derivative, it means that that is concave down. In other words, the shape looks like this. If I have a positive for the second derivative, it's concave up. In other words, as the concavity changed very close to that point 2, 3, that point is in fact a point of inflection. Let's practice this principle one more time in example number 2. Here I have a curve, and that is represented by x to the 4 minus 2. The question is, does this curve have a point of inflection? If it has a point of inflection, I must be able to find the second derivative equal to 0. So finding my first derivative of the function, I'm going to get that that is going to be 4x cubed. If I want to find the second derivative of the function in the variable x, that must be the derivative of the derivative, and that's going to be 12x squared. Now, if it is a point of inflection, then that means that the second derivative had to be equal to 0. In other words, 12x squared must be equal to 0. Well, that's a simple one to solve. The x value is going to be equal to 0. Let's see now if this was a point of inflection. If I had needed to find the y-coordinate of this point, all I would have done is I would have taken that x value and substituted it into my curve. Well, you can see when x is 0, the y is minus 2. So the point in question is the point 0, minus 2. But let's now focus on the 0. Filling in our value for x in the middle of the table, the x value that I found for the second derivative was 0. Now I'm going to choose a value for x to the left and to the right of 0. Well, an easy number to choose would be minus 1 on the left or 1 on the right. If I substitute minus 1 into my second derivative, I'm going to get 12 times minus 1 all squared. Well, that answer gives me 12. If I substitute that into with 1, then I'm going to get 12 times 1 squared, and that is also 12. Now remember, we're testing concavity, and I said that if that point 0 minus 2 was a point of inflection, then the concavity had to change. Well, on the left of that point, I'm concave up, and on the right of that point, I'm also concave up. So in fact, although that point 0 minus 2 is a point on my curve, it is not a point of inflection.